So now let us see the pulse position modulation. Now in pulse position modulation also, the carrier signal is pulse. So let's first see the output of this pulse position modulator output. So we can see that it's a train of pulses with equal distance among all the pulses, because as of now there is no modulating signal is been given to this pulse position modulation. So there is no modulating signal. So we can see that this is the unmodulated pulse which I am getting at the output, and all pulses are equidistant from each other. Now let's add the modulating signal. So let me add the modulating signal to the input of this. So let me connect first now the two channels of two oscilloscopes. Let me connect modulating signal. So I am connecting modulating signal to the pulse position modulation input. Let's see on channel 1 the modulating signal. So I can see that this is my modulating signal. And now let's see the output of PPM. So I am just connecting the output of PPM. Let me do the auto set. Now you can see that all that equidistant pulses are not now equidistant. So every pulse has changed its position according to the instantaneous value of modulating signal. If I change its amplitude of modulating signal now, you can see that position of pulses will again change. So if I am changing it, so you can see that the position of pulses has again changed. If I change again the instantaneous value of modulating signal, I am lowering down. So you can see that again the position of each pulse has changed. So basically when there was no modulating signal, all pulses were equidistant. But the moment we added the modulating signal, then according to the instantaneous value of modulating signal, that equidistant nature of pulses has changed, because position of pulses has changed according to the instantaneous value of modulating signal. So that is what the PPM modulation. Now how to get or how to derive the signal from this PPM output. So now connect same, let's connect this PPM signal to the input of filter. At the output of filter we should get a modulating signal. So this is the modulating signal. If we need to amplify, so then what we can do is you just connect this filter output to a AC amplifier circuit. So I am just connecting it to the AC amplifier input because the amplitude was less. At the output of filter, I am just connecting the output over here. You can see that the waveform which we are getting is clipped because amplifier went into the saturation. So let me change the biasing of my amplifier. I can see that now I am getting the modulating signal, the same which we had given to the input. So this is how the PPM works. So today we have seen the pulse amplitude modulation, 3 different techniques: sampling, sample and hold, natural sampling, which is the sampling circuit, and a flat top sampling. Then we had seen the pulse width modulation, and then we had seen the pulse position modulation.